let's look at branches. So the N5 course content states that you have to learn about molecular formulae can be written and structural formulae can be drawn from the systematic names of straight chain and branched alkenes, containing no more than 8 carbons in the longest chain. So what that means is that our aim today is by the end of this lesson you should be able to name the branches named due to the number of carbons. You should be able to write the systematic name for any straight chain or branch chained alkane or alkene containing no more than 8 carbons in the longest chain, and be able to draw any molecule containing no more than 8 carbons which has a branch. Hydrocarbon molecules are not always straight chained. However, they do have in their molecule a straight chain, but they have things going off at the sides which are known as branches. In this first example here, we have pentane. Now, pentane is a straight chained hydrocarbon, as you can easily see there. Isopentane, iso just basically means it's like pentane, but it's different. That literally iso means the same but different. I know that's confusing and I'll explain it later in a future lesson, but iso means the same but different. It is pentane, but it's in a different structure. And as you can see, it does have a long chain, but it also has a branch, and it has one branch that I'm just looping just now. We also have another molecule called neopentane, and neopentane has a carbon chain, but on this occasion it actually has 2 branches of that chain. That's the first one, and that one there is the next one. Okay. The above molecules are technically isomers of each other. Iso means the same but different, and mer means molecules. So they have the same chemical formula, C5H12, but they have different structures. So if you were to add this molecule up, you'd find C5H12. If you were to add all the carbons and hydrogens up, you would get C5H12, and the same again with this molecule here, you would get C5H12. So they have the same chemical formula, C5H12, but different structures, and that's what makes them isomers. We are going to be learning about isomers in a future lesson, but I just thought I'd bring it to your attention just now. So branches. We have another problem in naming. How can you tell someone that you have a branch on a hydrocarbon? Well, what you do is you use the suffix for that branch, which is "-ile". So "-ile" means joined on or joined onto, and the branch is named by the number of carbons that that branch has. So if that branch has 1 carbon, it would be known as methyl. If there's 2 carbons on that branch, it would be known as ethyl. And if there's 3, propyl, 4, butyl, etc, etc. So it's the same naming method that's used before, meth, eth, prop, but, pent, hex, hept, oct, that you've learned prior. Okay, so if we have a molecule that has, let's just put it, 4 carbons there, and that is the main chain. And we want to add a branch in this area here, this second carbon in, and it contains 2 carbons. We could go C, well, in fact I'll just do it as 1 carbon because it isn't going to work out with 2 for a reason that I don't really need to explain at this point. But we'll say it's got 1 carbon and we're adding that on to the main chain. Then this would be called meth eth prop but. So that's butane, and we're going to add the CH3 onto it, so we'd call that methyl butane. Now, because that methyl can be added anywhere in this molecule, it could have been added here, for example, or here, you actually have to state which carbon it's found on. So it's found in carbon, if that's carbon number 1, that's carbon number 2, it's found in carbon number 2, so 2-methylbutane. If I was to number the carbons from the opposite side, then that wouldn't work because the numbers would be too big. So that would be carbon 1, that would be carbon 2, and that would be carbon 3. So it would be 3-methylbutane, which is incorrect. But anyway, so the carbon chain branches are named meth, eth, prop, but with YL to signify that they're added on. You write them before the main chain with the number of branch it is on before that, as I showed you on the right there. Follow the same basic rules for this butane isomer. What do you think it would be called? Well, what you do is you find the longest chain. Now, I'm going to put my highlighter on here. If I was to go along here, 1, 2, 3, that is my longest chain. Alternatively, I could check here, and that would be 1, 2, 3. Okay, so the longest chain that you can possibly get with this molecule is 3 carbons in a chain. So to make my life easy, I like to, when I've got this situation where I've got 2 options of 2 routes, I like to just make the horizontal organisation of carbons the chain that I look at. It just makes it easier for me to visualise. So you find the longest chain, which I just showed you. That showed us meth, eth, prop, it's propane. You find the branches that's attached. Well, as you can see, there's a branch with 1 carbon being attached. So it's methyl. Keep the numbers as low as possible. Well, that would be carbon number 1 there, that would be carbon number 2 there, that would be carbon 3, or alternatively that would be carbon 1, that would be carbon 2, that would be carbon 3. So no matter which direction you look at this molecule, you're going to get the branch joined on to carbon number 2. So carbon number 2 is the number that we use. So 2-methyl propane. Try this one. What do you think this one's going to be called? Well, we find the longest chain. So you can see we've got 1, 2, 3, 4, 5 carbons in the long chain here. Or we've got another one here that if we started it off and joined it onto here and went left, you would also have 5 carbons. Okay, so it makes sense to make our life easier and use the horizontal straight chain because that one is maybe perhaps easier to visualise. So we know that the backbone is called pentane. The branch is the methyl group and it's on carbon number, well, if you were numbering from the left to the right, it would be in carbon number 1, 2, 3, 4. But if you number from the right to the left, you'd find it was on carbon number 2. So we want to keep our numbers as low as possible. So carbon number 2 is the number we assign. Look at this name. This one is 2,3-dimethylpentane. Di, remember, means 2. Tri meant 3. So 2,3-dimethylpentane, what do you think that means? Well, if you're thinking that it means that there is two branches, both of which are methyl, then you're correct. So one is at position 2 and one is at carbon 3. So if you try and draw that just now, draw your pentane backbone and draw your branches where they should go, you should get the right answer. You should have drawn a molecule that probably looked like that. There are, of course, several different ways you could have drawn this, and it still would have been correct. So if you're unsure, just check with your teacher if you feel you're unsure and you need to. But just to point out that you may have drawn this branch here. So you could have rotated this along that bond there, and so drawn that part at the bottom up at the top, or vice versa. This part at the top you could have drawn down here at the bottom. Okay, so more or less you look at your diagram and I'm sure you'll understand if you've done that correctly. Okay, so that part there, I just used the eraser there, that part there could have been drawn up there or vice versa. It doesn't matter. There is a hierarchy of functional groups that you need to be aware of. A double bond is more important than a branch. This is because the double bond is the functional group that gives the molecule its chemical properties. So carbons are numbered as low as possible to get to that double bond. So look at that molecule there. You can see how I'm numbering the carbons. In green, which is green because it's the right answer, I have numbered them from the right to the left to get to the double bond, which is on carbon number 1, or gap 1, as you remember, if that helped you. In red, we could have numbered left to right, like most people will probably do when they first see a molecule like this. But that would be incorrect, because that would mean the double bond is on carbon 3, when in reality, the double bond gets priority, and so therefore we number the carbons where it's joined to carbon number 1. So this molecule is called 3-methyl but 1-ene, not 2-methyl but 3-ene. So take a moment just to look at the correct answer, this bit here. Look at this molecule and understand why that makes sense. But, meth, eth, prop, but is the number of carbons. The double bond is in gap 1 or carbon number 1. And the methyl group is attached to carbon number 3 because we numbered them from right to left. There's one thing that's just occurred to me whilst narrating this PowerPoint that I haven't explained. When you have multiple branches, so when you have multiple branches in a molecule, you name the molecule with the branches in alphabetical order. So, say for example you have meth, eth, prop, but, pent, hex, hept. Let's do hept. Say I put a CH3 there, which is my branch. Say I put a C2H7 there, okay, and yeah, I think that's going to work. Right, so what you do with this is you would obviously try and find the longest chain. So if I'm looking straight along left to right there, I have 1, 2, 3, 4, 5, 6, 7. If I look from here up, I get 1, 2, 3, 4, 5, 6, 7. If I take it from the other branch down, I get, choose a different colour, 1, 2, 3, 4, 5, 6. No, that's wrong. 2, 3, 4, 5, 6, 7. Can't count. There's 7 there as well, right? So again, the easiest way, because we've got 7, no matter which way we look at this, is to go in the straight line which I've highlighted in green. So the longest chain is, of course, heptane, right? So we write heptane. Now, we've got 2 branches here. We've got this branch here, and we've got this branch here. Now, here's a little strategy I recommend when you get to answering questions on this. Write next from them what the branches are. So that one there's the methyl, so I would write in my jotter or on the question page in the exam that that's a methyl. And in here I have 2 carbons on my branch, so that's an ethyl. So I would go like that. And then, as you can see, we've got to number them in order to keep the numbers down low. Number the carbon chain, the longest carbon chain, to keep the numbers as low as possible. So if I was to number that one 1, that one 2, that one 3, 4, 5, 6, 7, that's going to keep the numbers down as low as possible because the first branch is at carbon 2 and the next branch is at carbon 3. If I was to do it the opposite way around, so that'd be carbon 1, that'd be carbon 2, 3, 4, 5, 6, 7. Well, you can see that that's totally wrong because the first branch would have came at carbon number 5 and the next one would have came at number 6. So the whole point is we want to keep the numbers as low as possible. And then you look at the branches and you'll realise that, well, ethyl starts with E and methyl starts with N. So even though ethyl is on the 3rd carbon in, you still have to name that one first because the branches are named in alphabetical order. So we're going to have a 3 ethyl and we're going to have a 2 methyl. So we need to add that in front of the heptane in alphabetical order. So I'm going to guess that I'll have to start here. So 3 ethyl dash 2 dash methyl heptane. Okay. So hopefully that's explained everything that you need to know in regards to branches. Complete the note on branches that you've been provided with in the class notebook. Then complete the tasks 2 and task 3 on branches. Really, this is just an aspect of chemistry that the more you practice it, the more examples that you're given, you'll get there. The penny will drop and you'll just understand it, and you'll actually quite enjoy completing them.